So Jeremy, here's the full and half-wave rectifier that we talked about. You can see the transformer on this side, the primary where 120 volts comes in, and then on this side there's 12 volts AC from these windings and 12 volts AC from those windings. But the current can only go in one direction, the direction of the arrow that doesn't have any dots on, because the current can only flow through the diode in one direction. So if we measured from this point to this point, we would see current flow in this direction, and we would get 12 volts DC over here, half wave rectified. We'd see the same thing over here, half wave rectified, but it would be the other phase. I'll show you a picture of that in a second. However, if we connected these two together, the current would first flow in this direction on one phase, and it would flow in this direction on the other phase. So here's the transformer with the primary and secondary, and it's really messy over here, but here's one diode, and here's the light bulb connected to that diode. Here's the other diode, and the red light bulb connected to that one. So now let's take a look at the scope. On the top line, we see the waveform coming out of one diode, and we can see it's the positive halves of the 60 cycles that are being rectified, and the line below is DC. Over here we see the negative cycles being rectified, and this is where zero is. So in that video that I just showed, these wires were not there. Now let's take and connect this to this, and we'll see what happens. So here's one diode, and this green wire is connected to it, and the green wire is connected on the plus side of that diode, and now I'm going to connect the green wire to the plus side of the other diode, and I'm going to expand back here so we can see what happens to the lights. They get brighter, and the reason they get brighter is because we have a full wave rectifier going into them. And we'll take a look at the scope, and there we are. Here's zero, and there's one cycle that's positive, and next cycle that's positive. We could have put a capacitor on that, then we'd see it filter out to be pretty much DC. So the next thing is, let's add a capacitor on the full wave rectifier output, this blue one. We're going to connect it up now, and notice what happens to the lights. It gets just a little bit brighter because the capacitor is able to fill in between the humps and keep the filament hot during the time that the voltage goes to zero. So this is what happens when you have a capacitor there. This is actually ground down here. This is one full wave hump. Here's the next full wave hump. But you see the hump never gets down to zero because the capacitor is holding the voltage up between the peaks of each of the AC humps. And if you put a lot of capacitance, you'd get just a flat DC line up here. That's it. Hope you enjoyed it. Love you guys. Bye.